we've illustrated at this point a number of different equations, and they can all be put into one of the forms that I'm going to write down here. One form is x prime equals f of t. And this form is always easy if f of t can be integrated. Okay, we just integrate both sides of the equation and we get a solution. Another form is x prime equals f of x. And I don't think we've actually looked at one of these, but this is easy if the function 1 over f of x can be integrated. Okay, the function x prime equals f of t x. Now this is in some cases could be sometimes easy, sometimes impossible. We'll just say sometimes not. We're going to spend a lot of time in the chapter 2 of your text learning to solve some of the equations of this form that are relatively easy to trick into solutions. Now all these equations are what we call first order equations. Involving x prime, the first derivative. Of x. We've also seen a number of equations that involve second derivative of x. I think we just went out of focus. There we are. Okay. These equations often arise in conjunction with Newton's second law, which relates the second derivative of your position function to the force function acting on a mass. So these things arise all the time. They're extremely important. One possible form is x double prime equals f of t. Now that's easy to solve if you can integrate f of t twice. We can integrate x double prime once to get x prime, integrate it again to get x. If we can integrate this side twice, it's easy if f of t can be integrated, and I think we're out of focus again. Okay. Twice. I guess we have to keep something in the center of the screen here. We'll try to redo this at some point. I would think that my moving hand would keep this thing in focus, but it doesn't seem to do that. Okay? Now, another form that we haven't seen is x double prime equals f of x. And we've seen examples of this. I don't think we've seen examples of this. It's easy if 1 over f of t can be integrated twice. Now the form x double prime equals f of, let's say, x prime, where t is not explicitly involved, and we've seen that with some of the pendulum examples. So this can be easy. I say easy. It can get a little complicated, but it's not really conceptually difficult. There's a simple trick that we can use to integrate this, and it's a subject of a later chapter. It's easy if f of f x prime is linear in x and x prime. Now, if x double prime is a function that involves t and x, or a function that involves t and x prime, or a function that involves t, x, and x prime, sometimes we can trick it and get a solution. Sometimes not. And of course, we'll concentrate in this course on the cases where you can trick equations of this form, of these forms into solutions. The most general form, and I guess I should, these are all second order equations. Now, general first order, x prime is some function that involves t and x. General second order will express x double prime as some function of t, x, and x prime. And in general, a higher order differential equation would relate some higher derivative of x to a function that involves t and the lower derivatives of x. Notice that each of these, x prime is a function of t and x double prime a function of t and the lower derivatives, the first derivative and the function x itself.